But our next speaker is Brian Becker, and he claims that he learned APL at the early age of 14, and now says that he's been doing APL for more than 3/4 of his life. So you can do the math and figure out what that means. And Brian has been involved with the APL problem-solving competition since its inception in 2009. And that predates his involvement with Dyalog. In 2009 and 2010, he was invited to be a judge of the competition. And then when he joined Dyalog in 2011, he continued to work on the competition, and it continues to be one of his favorite parts of the user meetings. So, if I did this right, duplicate. What's that? Okay. All right, so this is the prize ceremony for the 10th annual APL problem solving competition. And so the first thing I'd like to do is kind of review our history, go through the past, and talk about some milestones. In 2009, that was our first year, and Brooke Allen actually helped organize the competition, and it involved solving the first 20 problems on Project Euler. And the prize ceremony was held in Princeton, and again, that was my first involvement with the competition. In 2010, Dyalog took over writing the problems for the competition, and also added in some Rosetta Code problems. In 2011, Joel Huff was the winner that year, and in his presentation about his winning entry, he mentioned that he didn't find anything called Try APL. He knew that there were other programming sites out there to learn languages, and so that became the inspiration for the Try APL site. In 2013, student competitions started helping us with hosting the competition, and we introduced the 10 phase 1 questions and then the more complicated phase 2 questions. And we also changed the name from an APL programming competition to problem solving, because really I think that's what the focus should be, is that we solve problems with APL, and at least my coworkers would admit that I'm not a very good programmer, but I'm an okay problem solver. And in 2014, we started recognizing, we always had a number of entries from people who were not students. The competition was organized primarily to try and attract new APLers, but we had a number of people who already knew APL in their professional lives that would submit entries, and we wanted to try and recognize their submissions as well. And then in 2016, we switched to having some domain-specific phase 2 question types. So, now the other thing I'd like to do is to talk about some of our alumni from the competition. The very first winner, Ronald Chan, actually interned at Dyalog for a while and contributed some work on the interpreter. I think in Domino, if I'm not mistaken. Is that correct? Yeah. And the next year, or when Ryan Tarpine won, he contributed a number of the problems for the following year's competition. And those were some of the best problems we've ever published. They were quite good. And I don't know why it's double clicking, but that's okay. Joel Huff, who won the following year, again, he was the inspiration for Try APL, but then he co-presented at a conference with Morton on why APL is so cool. So, Marinus Oosters, who won a few years ago, did some work with Dyalog and produced the Pineapple Python interface for Dyalog APL. And then we've got Josh David, who's here with us this year, and he's done some interning and work with the Carlisle group. And then we also have Zach Batik, who is the chief APL developer at RiskFlow, and Zach contributed a number of the the problems for this year's competition. So we've gotten some good feedback and some good mileage out of our past participants. Now, if we look at this year, again, we had 10 phase 1 problems. And so here's one of them. Here's problem number 1. Imagine you're standing in front of a line of skyscrapers of varying heights. And you can always see a skyscraper that is taller than a closer skyscraper. So how many skyscrapers can you see? Okay, so what would be an APL expression to come up with for that? So we won't mull over that for very long. Another problem, problem 10, was write an APL expression that given right and left arguments of character vectors, discounting spaces or punctuation, you'll return a 1 if both arguments are anagrams of one another. So this was actually kind of interesting. There was a variety of kind of neat solutions here. One of them was to use a function and an operator, right? Take out the spaces, sort them both, and then do a comparison. And another was, and again, we won't linger on this too long, but if you want these, they'll be on the slides. Also, we had our phase 2 categories this year were in cryptography, neural networks, and physics. And I always like to try and reflect some of the reactions that we got back. We asked for feedback from the participants every year, and so this is some of the feedback that we got. Problems were engaging enough to keep me awake until midnight, and it was the eloquence of APL that kept me coming back to where I had left off. The problems were intriguing, their descriptions comprehensive, and accompanying examples illustrative. Above all, learning APL itself was a breeze. Rats. I had a hard time when I was 14 years old, so a few words about APL. APL codes tend to be terse. For instance, a single line of APL can accomplish what other languages can't in 10 lines of code. Besides being intuitive to implement, APL programs are easy to debug. So he's clearly never tried to debug salt. Another one said, I enjoyed all of the competition problems I solved. This is my first exposure to real problem solving in APL, and it has been a wonderful, though sometimes foreign, or oftentimes foreign, programming language. And then my favorite, I like brevity. APLers like brevity, really enjoyed the contest. So in the future, well, we're always looking for new problems. And so what we look for is problems that highlight the strengths of APL and have a definitive solution. We've had problems in the past where we've had to do simulations. And the problem with simulations is you can get a wide enough range of results that it makes it a little hard to judge a lot of entries if we happen to get them. And then we're also looking at, every year we do an evaluation of each year's competition. And so we might, look at changing the way we've been hosting the competition or the types of problems that we're going to be giving out, and maybe the timing of the competition to make it overlap better with the academic year. So again, if anybody has any type of suggestions or wants to contribute to those efforts, please let us know. So we can't run a competition without a lot of help. And I want to thank Fiserv, SimCorp Italiana, and our anonymous sponsors for their support since the beginning of the competition. So for 10 years, these generous entities have been supporting the competition financially. Dyalog, of course, has been coordinating and hosting it, but to subsidize the prizes and people's travel and things like that, we just couldn't do it without your support, and so we thank you very, very much. I want to thank Student Competitions for hosting, and I'd like to thank Zach. Zach, where are you? Someplace? I can't see. There he is. Zach contributed a number of the Phase 2 problems this year, and from a nice variety of problem sets, very interesting problems, and so we really appreciate his contributions. I'd like to thank Roger. Roger contributed a number of the Phase 1 problems or ideas for the Phase 1 problems, and he also wrote an excellent blog post, which if you haven't read it, go out on the Dyalog blog site, and where he talks about the 10 Phase 1 problems and describes their solutions. So I want to thank Adam and Mikhail for helping judge the entries this year. We had a lot of entries, and there was a lot of stuff to go through. Adam actually automated a lot of the phase one judging, and populated a spreadsheet with color. It was great, so that helped quite a bit. And finally, I want to thank Fiona. She helps just keep things organized. She was my main go-between between myself and student competitions, and so she got to deal with flack coming from both sides, and she was a nice buffer there and kept things flowing smoothly. So now we can talk about the results. I'm actually running way ahead of time. I don't know how I managed to do that. So for phase one, we had 42 entries, and 26 were from students. And for phase two, we had 28 entries, and 20 were from students. And most of I think all of the phase two entries had also submitted phase one, right? So in third place, we have Rafael Rodriguez Rocha de Melo. And when I read Kyoto University in Japan, there seemed to be an incongruity there, but indeed, he is studying in Japan. In second place was Lynn van Houwe from the University of Antwerp. In first place, in the professional category, the non-student category, we've got Tiziano Berghi, and from SimCorp Italiana. And Tiziano, if you're here, yes? We have a certificate for you. Congratulations on a great entry. And in first place in the student category is Alve Björk from Uppsala University in Sweden. And I would like to ask Lavinia Zyvith to come and present Alve with his prize, and then Alve will tell us a little bit about the work that he's done for the competition.
So just a little word about, I'm Lavinia Zyvith from Fiserv, and as Fiserv member of the APL team, we are very honored and pleased to have been involved with this competition since day one. So it's incredible to know that it has been 10 years, and over the 10 years, students from 8 different countries have been won the grand prize and have been part of these user conference and present their creative and very thoughtful process of using APL as a very unique tool to approach problem solving. So it has been fascinating over the years to see all the students that come through the door. So this year we're very pleased to have Alve Björk, and I've learned to say your name properly, and to share with us his process and experience in learning. Thank you.
Thank you. And Alve says that he has got his own little biographical background to present during his presentation. So without further ado, Alve.